Hi all, welcome you all to this new lecture today. So this lecture we are going to see about the fluid power systems and hydraulics pumps. So in this topic, the topic what we are going to see is vane pumps. So before that, let us go a small recap, briefly recap or recall gear pumps. So gear pumps are simple, inexpensive, and widely used, but they offer a lowest level of performance. So their efficiency reduces rapidly due to wear and maintenance costs are relatively high for gear pumps. So to overcome this limitations in gear pumps, we commonly use other type of pumps called as vane pumps. So vane pumps are positive displacement rotary pumps. They are using sliding vanes to move the fluid inside the casing. They provide a smoother flow compared to gear pumps, and they also operate with a better efficiency and reduces noise. We are having three different types of vane pumps shown: unbalanced vane pump, a balanced vane pump, and pressure compensated vane pump. We'll see one by one in the later slides. This image shows the construction of a vane pump. So the vane pump consists of a rotor with radial slots arranged, and their vanes are mounted inside the slots. A cam ring is also present inside the housing. The vanes slide in and out of the rotor slots, and they maintain a contact with the cam ring due to centrifugal force. And we know it is loaded with a spring, so every individual part is mentioned here in the diagram also. So the oil enters inside the space between the ring and the rotor, and in the second stage it is carried around the ring in the pump chamber. Then in the stage 3, discharge occurs as the space is also decreased. That is it. It is very smoother, and in 3 stages we are going to pressurize and transmit the fluid from the inlet to the outlet stage. Then in an unbalanced vane pump, the rotor axis is positioned in an eccentric manner. It is the respective to the circular cam. During the first half of the revolution, the volume between the rotor and the cam increases, creating suction. During the second half, the volume decreases, so it results in discharge. At least one vane always separates the suction and discharge slides, preventing leakage. So this is the condition here. In a balanced vane pump, the rotor is concentric with an elliptical cam ring, and the vanes reciprocate twice per revolution, producing two pumping actions. So when the first vane it is sucking the fluid, the second cam ring also will be sucking. The vanes reciprocate twice per revolution. So there are two inlet ports and two outlet ports. This diametrically opposite, which balance the hydraulic forces. This design reduces bearing loads also. Then the features of a balanced vane pump is shown here. Variable displacement can also be occur. Balanced vane pump operates up to 175 bar pressure also. So that is the maximum range in which the vane pumps can be operated. Then pressure compensated vane pump is shown here. So in pressure compensated, automatically adjust the displacement between the system pressure. When the set pressure is reached, the pump reduces flow, improving efficiency and protecting system components. The advantages and disadvantages of the pump is shown here. Vane pumps can handle thin liquids, relatively higher pressure, compensate wear, and develop good vacuum. And that is sometimes preferred for solvents and LPG also, because of relatively higher pressure compared to with the internal gear pumps also. And due to the wear and tear, we'll be using this for solvents and LPG transmission. Then they also have a higher complex construction, which is not suitable for very high pressures. It is relatively higher, but not for very high pressures, and cannot handle high viscous fluids also, because we have already seen the vanes are arranged in the rotors, slides, so slots. So very high pressures cannot be achieved. And this is a small quiz here shown here. So what is the trade-off for hydraulic pressure? and which pump operates at 12,000 psi, and in Pascal's law, if current pound has to be applied in 1 square inch stopper, then what is the force required, and what is the formula for volumetric efficiency, and the advantages of fluid powers for safe operations in hazardous environments is also listed here. So I've also given you the answers, so you can refer the answers when required. So to summarize here, the Vane pumps offer balance between gear pump and piston pumps in terms of cost and efficiency, and they have a good efficiency, longer service life, and a moderate leakage losses also. To conclude, Vane pumps are widely used in fluid power systems where smooth flow and moderate pressure and reliable operations are required. Right? Thank you.